Hi everyone, I am Gokila S, Assistant Professor, Department of CSE, Hindustan College of Engineering and Technology. Today I am going to explain a concept of deadlock from operating systems. Deadlock is like an error. Lack of process synchronization results in deadlock. When two or more processes waiting to access the same resource at that time a deadlock may occur. In deadlock, none of the process can run and none of the process can release resources. Deadlock occurs on shareable resources like files, printers, disks, tape drivers, main memory, CPU cycles, etc. There are various ways to handle deadlock. That is, ignoring deadlock, deadlock prevention, deadlock avoidance, and deadlock detection. Now we are going to see each and every way of handling deadlock in detailed manner. The first one is deadlock prevention. There are four methods for this deadlock prevention: mutual exclusion, hold and wait, no preemption, and circular wait. The first one is mutual exclusion. Each resource is assigned to at most one process so that there will be a mutual exclusion between the different processes. The second one is hold and wait. A process holding resources can request more resources. And the next one is no preemption method. Previously granted resources cannot be forcibly taken away by any other processes. And the last one is circular wait. There must be a circular chain of two or more processes where each is waiting for a resource held by the next member of the chain. Deadlock avoidance. Deadlock avoidance examines the resource allocation state, whether all the process has been allocated by some resources, and it also examines a no circular wait condition. The state of the system will continuously be checked for safe and unsafe state. Deadlock avoidance. Coming to the safe state and unsafe state, if there exists a sequence of all processes, then the state is said to be in a safe state. Then there is a no option for a deadlock. If there is no any sequence of processes, then it is said to be an unsafe state. There is a possibility of a deadlock. Deadlock avoidance. Deadlock avoidance can be done with Banker's algorithm. This Banker's algorithm tests all the requests made by processes for each resources. And also, this Banker's algorithm will helpful in checking for the safe state and also in multiple instances. Always this Banker's algorithm can be solved analytically by means of having various processes and having various resources. By means of analytical method, we can check whether that all the process are there in a safe state. Deadlock detection. Deadlock detection, it run an algorithm to check for cycle in resource allocation graph. Presence of cycle in the graph is the sufficient condition for deadlock. We can go with this example for deadlock detection. In the given example, there are two processes, process 1 and process 2. Also, there are two resources, resource 1 and resource 2. Resource 1 is assigned to process 1. Resource 2 is assigned to process 2. When there is a process 1 is in need of resource 2, this process 1 has to be wait to access the resource 2 because already this resource 2 is assigned to process 2. By means of this chain, we can find out the deadlock detection. These are the various deadlock handling methods. Thank you for listening.